This movie is for Learning Target 5, Congruence Transformations. So in this warm-up, what I want you to do is get a piece of tracing paper or just a piece of paper that might be kind of thin that you could use. And it doesn't need to be a big sheet of paper. And I want you to fold that in half, draw an image on one side, which we're going to call the pre-image, fold and trace the image on the other side. Then I want you to think about what properties make these two images identical. So here I have my piece of paper. I've got the fold as the blue line, and I've created the pre-image here on this side. Going to my image here. Now you might state things, what makes these two properties that make these two images identical is that they have corresponding side lengths. Those are congruent, these are congruent. These side lengths, CB is congruent to C prime, B prime. So really by side, I could prove these two triangles congruent. I also know that the distance between B and B prime, if I take that in half, I've got the fold. So the fold becomes the perpendicular bisector between the pre-image B and the image B prime. Same thing is true between C and C prime. Same thing is true between A and A prime. So the fold becomes the perpendicular bisector between those 2 points. So we have a reflection here. So we have an example of rigid motion. And we can talk in terms of a transformation that occurred, taking us from the pre-image to the image. And in this case, it is a reflection. You may have used properties of rigid motion to describe why the wings are identical or why your shape is identical to itself. Congruent figures. Two figures are congruent if and only if there is a sequence of one or more rigid motions, which include our transformations of translations, rotations, and reflections, that maps one figure to the other. And so we're going to look at rigid motion. Which pairs of figures in the grid are congruent? For each pair, what is a sequence of rigid motions, meaning is it a translation, rotation, reflection that maps one figure to the other? So I'm going to pick two out here. It looks as though these two are congruent, and I'm going to prove that they're congruent. So what I want you to do is pause the movie, try to figure out a series or just one transformation that maps one to the other, and I'm going to start with DEF. Okay, to take DEF and take that to the other triangle, LMN, what I'm going to do is figure out, well, it kind of looks to me like the orientation is different. It looks like it went around this way as if it were rotated. So the orientation is definitely different, like there's a rotation involved in it. Because it started in quadrant 2, ends in quadrant 4, I think it's a rotation of 180. Now I'm going to prove that that's true. So I'm going to get my points for D, E, and F. D is at negative 5, 1. E is at negative 5, 5. F is at negative 1, 1. If I have a rotation of 180, then my point xy maps to negative x, negative y, giving me a D prime of 5, negative 1, an E prime of 5, negative 5, and an F prime of 1, negative 1. And if I plot those, 5, negative 1, 5, negative 5, I get this triangle. So that is my transformation that proves rigid motion with those two triangles. And my sequence of rigid motion is a rotation of 180. Now, if I highlight this figure, ABCJ, I think it's going to map to this one. And so what I need to do is find a series of transformations that maps one to the other. So I'm going to take AB, CJ, and map it to WXYZ. And it looks like the orientation has changed, because if I look at this right here, these two sides, they end up flipping. So what I think is happening is some kind of reflection, and I think a reflection over the y is what I'm going to start with here. So I'm going to start with reflect AB CJ over the y-axis first. And by doing that, B 1 2 1 2 becomes here B prime. A 1 2 3 4 1 2 3 4 ends up being here. C prime is here, and J, which is at -6, goes here. J prime. So I get that triangle. Let's highlight that one. And then if I take that, not triangle, sorry, trapezoid. If I take this trapezoid and I translate it, it looks like I need to go to the left one and then up 1, 2, 3, 4, 5. And then the left one, 1, 2, 3, 4, 5. It seems to work on all of them. So now the second thing I'm going to do is translate left 1 unit and up, what did I say, 5? Up 5. So translate x minus 1, y plus 5. And that's my notation for writing that. That will take me from one trapezoid to the other. Series of transformations. You could also translate PQ to HG. We're going to move on to this diagram. And I want you to look at a series of transformation that maps this triangle to this triangle. The other one is a straightforward translation. So I want you to look at this one because it appears as though the orientation is different. So we're going to try to map this triangle MN QMN to the other triangle. So pause the movie, try that on your own, and press play when you are finished. Well, the first thing, I could investigate a rotation of 180 about the origin, but it looks like to get that orientation, I'm going to look at doing a rotation of 90 degrees. So the first thing I'm going to look at is rotate 90. Now you might think, could I do a different series of transformations? And the answer is yes, you absolutely could. So this is just one sample. If I'm looking at my points, I know that I've got my points for rotation about 90 degrees XY maps to -YX. So that would give me point M prime is 1, -3, because this is taking -3, -1, and using that pattern to get 1, -3. And then N, which is located at -2, 1, 2, 3, 4, -2, -4, becomes N prime, which is 4, -2, 4, -2, N prime. And then Q, which is -5, -3, becomes Q prime of 3, -5. Now, if I connect these guys, connect them here, whoops. I get that triangle. So that looks like the orientation of my UVW. So now it's a matter of a translation. So my second step would be a translate of, it's not going left or right. So I'm going to put x plus 0. You could just have x. But then I'm going to go up 1, 2, 3, 4, 5, 6. So a translation of not left or right, but up 6 will give me UVW. And so those are the series of transformations of rigid motion that took me from one triangle to the other. All right, let's go to the next page. Because compositions of rigid motion take figures to congruent figures, they're also called congruence transformations. In the diagram here we have two figures. What is a congruence transformation that maps JQV, so this is my pre-image, to EWT, my image? So now you know which one you're starting at and which one you're going to. Pause the movie, press play when you are finished. All right, starting at JQV, looking down here, it looks as though I'm going to need to do a reflection and a translation. So the first thing I'm going to do is translate. JQV. And I'm going to go not left or right, so I'm going to go x plus 0, but I'm going to go up 5. And here's why. If I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, I get this guy. And it appears as though that one now just needs to be reflected over the y-axis. So my second step is to reflect over the y-axis. Does it need to be in this order? No. Could it be in this order? Yes. Could I have these flipped? Yes. So there's lots of different answers you could have here, but for me, I'm translating up 5 and reflecting over the y-axis. Pause the movie, try this one on your own, and then press play when you are finished. So for this one, a sample one, now we're going from NAV, that's my pre-image, to my image. The orientation is different. So there's going to be some kind of reflection or rotation involved here. The first thing I decided to do was to reflect over x-axis. So that took me NAV, reflecting over the x, 1, 2, 3, 4, 1, 2, 3, 4, and prime went here, 3, 1, 2, 3, A prime here, and V prime here. So, having that, now it looks like the orientation is the same. Now I just translate, so my second thing is to translate, and I'm going left 5, 1, 2, 3, 4, 5. So that means x minus 5, but I'm not going up or down, so I'm just putting that. And those are the series of transformations I have. Now these are sample answers. The same will be true when you complete the homework. But that's the end of our Congruence Transformations lesson. Thanks for watching.